Assalamualaikum and hi everyone. We are from Group 3 and we are going to present our idea for the embedded computing system. These are our group members, which consist of me, Nabilah, Yong Zi Xian, Qiao Li, and Sneha. So the application we chose that is related to embedded computing system is a smart IoT vest. This IoT-based vest is aimed for a number of people, which includes patients who have been diagnosed to have high risk of falling, patients who have a minor fall before and is likely to fall again, and patients in the hospital who are bedbounded and should not be moving around. An example of these patients can include senior citizens and many more. This vest is also used to predict the user's movements using machine learning algorithms. So, why is this vest needed? This vest is needed due to the aging population in Malaysia that leads to an increased risk of falls among the elderly. And researchers have stated that falls among Malaysian seniors have an incidence of approximately 8.5 falls and 3.2 recurrent falls per 100 person years. Falls can result in injuries, hospitalizations, increased dependency, deaths, and many more. Other than that, falls can also increase the economic burden of medical costs and the need for social care. In addition, based on the statistical data provided by Canadian Vital Statistics, it is observed from the graph that from 2001 to 2019, the annual number of deaths, crude and age-standardized mortality rates due to falls increased among people aged 65 or older. And in 2019, 5,581 older adults died because of a fall. During the 2001 to 2019 period, the age-standardized fall mortality rates rose from 41.0 to 86.4 per 100,000 people, showing a 111% increase. Therefore, there are enough reasons as to why this vest is necessary.
Now I will move on to the next part, which is futuristic features. During the design phase, we focus on what makes the vest special for future. First, we think about the comfortability of the patient or the user of this vest. We embedded an automatic vest fit system based on various posture and movement. Besides, the vest made with shape memory materials and smart fibers. By integrating smart fibers technology, the vest has distributed pressure sensing, temperature sensing, and actuatory tasks like health monitoring, energy harvesting, or active vibrating damping. Next is fall prevention. Airbag fall protection system is one of the futuristic features for the vest. The system will be triggered before impact. For some situations, the system will activate and airbag system will work up to protect the wearer from hurt. The protection area of the airbag included hip, head, and back protection. The vest is applying unique Internet of Things and have ability to connect and control various systems. It equipped with sensor and technologies which app connected will continuously display the data from sensors. When the system detects abnormal situation, an alarm is automatically triggered for both apps and vest itself. We can see the picture on bottom left is LilyPad Arduino mainboard. It is designed for wearable object and is suitable to embedded in our smart Internet of Things vest system. Few characteristics such as waterproof and durable, 32 GB storage space, Bluetooth connection, and able to hold a single 3V CR2032 coin cell battery. Besides, the rechargeable battery covered by fire retardant cloth and impact proof to maximize safety. When it comes to charging, the rechargeable battery is almost the size of an AA size battery and compact and handy with low capacity. It can be removed and charged externally. In our application, We have various systems such as on-off system, notification system, emergency alert vibrate, and emergency contact. When abnormal situation happen and wearer does not have any response, alert will send to emergency contact and action can be taken in short time.
Now I would like to explain the flowchart which demonstrates how this smart Internet of Things vest works. The system will start once the patient wears on the vest. Next, the vest will fit according to the patient posture through the sensor. For example, when the patient is walking, sitting, or standing. The user has to activate the application in their smartphone so the vest can monitor the movement of the patient, and the fall prevention system will start to detect. If there is an abnormal activity or a risk of fall or injury detected, the system will be triggered and alert the patient. If the patient falls or any injury happens to them, the system will automatically contact the helpline, and at the same time, the system will also provide emergency information to the hospital. But if the condition is safe and nothing happens, the system will continue to monitor the patient. The system will stop to scan or monitor them once they remove this smart Internet of Things vest.
Now we'll move on to the fourth part of our presentation, which is the state transition diagram. And this is the diagram. So I'll proceed with the working application of this fall prevention system, where it starts when the patient puts on the vest, and based on the patient's movement and also their posture, the vest will automatically detect and also will adjust according to the patient's feet. And then the monitoring system will be activated at the same time. The user has to on the application in their phone, they has to activate in their phone. And when there's any abnormal activity detected, or there's a high risk activity detected, the system will automatically be triggered or vibrate, and the user will be acknowledged through the push notifications and also through a emergency call. That means the user will receive an emergency call saying that there's an abnormal activity detected. And then other than that, if there's any fall or injury detected, the system will automatically contact the helpline, which is the 999, and then also it will acknowledge that there's an emergency here. And then this incident happens when the user ignores the first trigger, or that means the first alert given by the system. And then when the emergency is resolved, after the emergency is being settled, the vest continues to monitor the system of the patient, the health system, if the vest is not removed. If the vest is removed, the system automatically will be not activated. And then this system predicts very much accurately because there's a help of artificial intelligence algorithm. That's all from us. Thank you.